Hi, everybody. This is Sam Zipper, the project director for the USDA-funded SAFE KAW project, studying the future of the Kansas River watershed. Welcome to our first stakeholder update video. We plan on putting these out every month or two, rotating among our different teams to provide quick highlights of what we're working on. Today, the water quality team, Erin Seybold, Shreya, Chatterjee, and Camden, Hatley will be sharing their work. If there's anything in here that you have feedback on or want to hear more about, please drop us a line and let's talk more.
Hi, my name is Erin Seybold, and I'm a scientist at the Kansas Geological Survey, and I am helping lead the water quality component of this project. So as part of Project SAFE KAW, we're combining two approaches to understanding the impacts of climate change and agricultural adaptation on water quality. The first is focused on using historical data to identify the key drivers of annual nitrate loading, and then using these relationships to predict nitrate export under future climate scenarios. And this is work that's being led by Shreya Chatterjee, a graduate student on our project. The second approach is leveraging high-frequency data from a USGS gauge to look at event scale nitrate export, and then using statistical models to determine what factors influence both the sources as well as transport of nitrate over short timescales. And you'll hear more about this from Camden Hatley, another graduate student on our project. So when combined, these two approaches give us a strong understanding of the controls on nitrate export from event to annual timescales, and this can help us predict export under future scenarios.
Hello, I'm Shreya Chatterjee. I'm a first-year PhD student working with Dr. Erin Seybold. Broadly, I'm working to identify the drivers of nitrogen loading to the Kansas River and to build a model to predict how the nitrogen loads will respond to the agricultural practices and climate and land use changes. I have started by acquiring the surface water quality data from NVIS and store it using the data retrieval package. I'm quantifying the spatial and temporal coverage of the available data. The map here shows the locations from where the NVIS and stored data has been collected, where the blue dots represent the stored locations and the red dots represent the USGS gauge locations. However, the available data is temporally sparse, so to interpolate the missing data points, I have used the weighted regression on time, discharge, and season approach. The next steps would be to gather the data for potential predictive variables, including precipitation, temperature, and land cover, and to predict the future loadings based on the present scenarios.
Hi, my name is Camden Hatley. I'm a graduate student on the SAFE KAW project, and I am currently studying the event scale dynamics of nitrate concentrations in the Kansas River. So every single flow event that happens in the river, whether it's driven by precipitation or by reservoir releases or some combination of the two, every single flow event can produce a different type of response in nitrate concentrations. So some events produce these huge spikes in nitrate, some events just produce little bumps in nitrate, and a lot of events actually act to dilute nitrate down to lower concentrations. And what I'm trying to figure out is, can we predict which kind of nitrate response we're going to get from any given event? So for each flow event in the last decade of record, I'm looking at the type of nitrate response that happened, along with event-specific factors like the initial conditions in the river, the timing and frequency and intensity of precipitation, and the amount of water that's being released from each major reservoir in the basin. And I'm trying to find consistent relationships between these factors and the types of nitrate responses that came out. And the big idea behind all of this is to eventually use this information to forecast potential water quality risks in the river under future climate scenarios.